Whenever you speak about compartmentalization, what this slide clearly speaks is, I mean, this I've taken a snapshot from NBC, volume 4. Part 4 is what I've taken, volume 1, part 4. Anyway, so whenever you have this compartmentalization, for non-sprinkler building, whatever might be the building, it will be 750 square meters. But whereas for sprinkler building, your compartmentalization, according to the application, it will be. For example, if you consider like basements of car parks, 3000 square meters. Other than car parking, if you have any basements for utilization, it will be 2000 square meters. For institutional buildings, 1800. Mercantile building, 2. Business building, 3000. Like that, according to the type of building, you have this compartmentalization. More than that, if you have, it's mandatory for you to go for water compartment, like a water curtain system. So it need not be water curtain system, as I've said. You can even have something called as you've got fire curtains, which will be like a canvas, so which will be enrolled straight on the top. So whenever there is a fire, it will roll down. Listen. So those are basically called as fire curtains. Any one of the things are required. So whenever you have a water curtain system, it's quite simple. We run a pipe along the separation where we want to separate it, and we'll have a deluge valve. I'll just explain you in the drawing. Uh, Shit, I might have opened a CAD now and not be able to. Can you disconnect for a while and I'll connect back if you don't mind? Because AutoCAD issues are no, so I have to disconnect. I mean, without internet, I have to switch it on. That's the reason.
No problem. No problem. We'll be in the call.
Yes, just a second. Sorry. Yeah, you able to see the screen?
Not yet. Not yet.
Not at
Oh,
sure.
sorry. The screen sharing option is gone. Yeah. Hope now you're able to see the screen.
Yes. Yes.
Yes.
So let's say I've got a room space. Let's say I've got a room space of dimensions 100 meter, say 90 meters by 9,000, 3,000 by 90 meters by 80 meters. 8,000 and huh. So we've got a particular room space. So this is, let's say, is a basement or whatever it is. So if you consider the basement, let's say this example, as per the slide, for any basement car parks, if I have a sprinkler system, generally, if you consider like, business buildings, 99%, I mean, if the height is above 15 meters, it's mandatory for you to go for sprinkler system anyway, right? So if you consider this basement car park, you have an area of 3,000 square meters. Now, what is the area I've got it? So it is
7,002.
7,200 square meters. You agree?
Yes, sir.
So 7,200 square meters means, don't you think I have to make it into 3,000 means, don't you think at least I'll require some three compartments or not?
Yes. Yes.
Yes,
We
sir.
need for
Right.
three compartments.
Right. Definitely, you might get something like this. So when you have this much bigger building, you'll have different lifts to have this thing. You'll have a lifts for sure, mostly. Yes or no?
Yeah.
You might have some kind of lifts or anything. Why this? Okay. Okay, because it's not selecting as it. You might have some lifts over here, some kind of staircase to the peripherals. You can have any of those things anyway. So generally, your lift directions will be 1.6 or 2 meters by 2 meters, not more than that for sure. Yeah, this will be a lift size most of the cases. You might have some lifts, and you might even have some staircases also to the center. Right. So I'm just drawing a physical thing just for you to understand. That's it. Suppose I'll draw a staircase. I guess that will be better. Because generally near the left, you'll have a staircase as well. Let's assume you've got some small fire exit staircases also. Okay. I'm just randomly giving a practical example. That's it. So the bigger rectangle is showing the staircase, fire exit staircases. Okay. You can have something like this inside your building, right? So now you have to cater into, I mean, you will definitely have your ramps, all those things will be there anyway inside your basement areas for the vehicles to come in and go out. Right. So now we have to work on the compartmentalization. So I should make sure that the area is not greater than 3000 square meters. Understood? So if you take it, I can draw something like this probably. Let's take something like this, possibly. From here to here, I can take it. And probably like this. Let's take the area should not be greater than 3000 square meters anyway. Let's, what is the area? 29164. In that, in fact, this will be fire because your staircases, will, in general, all the fire exits will be surrounded by walls. So that area also we have to remove. If I do not remove, also it is coming down to how much? 2916. So it is lesser than 3000 or not?
Yes.
Yes.
Right. So other areas also we can calculate it. What is the area we have it? This is how much area?
215.
2154. So it is also lesser. And then this area also will take it. This also will be lesser. 212 is that. So that is also still lesser than the 3000, right? So we have segregated into three areas so that every area is not greater than 3000 square meters as illustrated in NBC or as per our NBC code. Am I clear?
Yeah.
So now I'll try to, well, like, change this a bit. Just a sec. For my ease of this thing, I'll probably split it like this. I'll push this in this direction. Just a sec. Let me put it down and see. So this is 2 9 is coming. So what I'll do is this rectangle, I'll split it at this location. This location is what I'll make it as a zone 1. The edge wall, I'll take it for my ease of construction. That's it. So this is my coordinates. Similarly, I'll take it at this location also. This is my coordinates. So if I see this areas over here, this should be lesser than 3000 square meters. 27 it has come. Let me see the right side. I guess right side also it should be lesser anyway, but let me just cross check. Do 4, so we are safer. Yeah, lesser than 3000 square meters is what we're doing. Now, at these locations, we wanted to place our nozzles. Understand? So, whenever you speak about water curtains, so I mean, you have to ensure that the water curtain nozzle is near to the wall. That means in this section, if I draw it, let's say, just a second. There's a building thickness, let's say 300 wall, 300 thick wall, let's say. Okay, and you will definitely have a lot of beams or not inside the building. Beams and columns will be there. Hello.
Yes, sir.
So you will definitely have your beams columns. Let's say this is your beam and this is your column. This is your beams, let's say 600 or something. Then whenever you have a water curtain pipe, your water curtain pipe should nearly, wait, 25, 25. Okay. Your water curtain pipe should bend like this and then it should go back to the slab. It should never be just be in this direction because you'll have a lot of space in that case. It's better to avoid as much as possible. Understood? When you install a water curtain, you have to carry it near to your slab always. Please remember that. Understood or not? Or if you have beam exactly underneath without any column parallelly, take it exactly near the beam because anyway, beam itself will act like a fire barrier, right? So beneath that, see that means if you have in this section, you can take your pipe in this, but generally you have columns and all exactly that's coming under the intersection of the beam. That's the reason we don't do it. Or else you can take your pipe something like this. Understood? So 150 like that, you can have a gap, but no, not like 2 feet like that. It's not allowed. Understood? While installing the water curtains,
Yeah.
nozzles. So whenever you have your water curtain nozzle, your nozzles will be something like this. This is how you have your, you can see on the top. Yeah,
Yeah.
the image on the
Yes.
top. So that
Yeah.
is nothing but your water curtain nozzle. Okay, or water curtain open sprinkler also we can call it as if you want. But there's one more type which is open sprinkler that we use it for text line. But generally this is your water curtain nozzle. So whenever you have this water curtain nozzle, so it is simple. I've clearly given how we design it. So you can read it out or else I'll read. So water curtain sprinklers. Sprinklers in water curtain shall be suitably designed to provide a discharge of at least 35 LPM for every linear meter of openings. And it shall be ensured that each sprinkler discharges between 55 to 80 LPM at 1.4 bar pressure, depending upon the spacing between the nozzles, which shall not exceed 2.5 meters. That means when you place your nozzles, the space between them will not be more than 2.5 meters, and at least it shall discharge 55 to 80 LPM. So that if you discharge, like, when you take the length of that particular one, for every meter, more than, like, minimum it should have 35 liters per minute. Understood? Am I
Yes.
clear or not?
Yes.
Okay. So now what we have to do is we have to calculate the total length and then we have to decide how many number of nozzles we require and then we will design the system. Am I clear? So
Yeah.
if I wanted it, how we are going to do is let's say, yeah, simple at this location. So I'll just draw that. Just showing it like this as my water curtain nozzle. So this nozzle, I'll place it in, yeah, this nozzle, I'll try to place it from the wall. We'll keep it like, around 1 meter distance if you want, we can have it. So from here, I'll keep a distance of 1000 From here, I can take a distance of around 2 or 2.5 meters. So let's take 2 meters. Area as well. Understand that. So we're placing it here. So here it is lesser than 2 meters, so that's fine. Again, I'll bless it. So here to this wall. Let's this I'll probably do. Because that's 2 meters. I don't want 2 meters. That's just fine. So place the number of nozzles here. So now this is the total nozzles we have got. Now I have to calculate what is 10 length of this particular pipes. So, so when I have it here, so you try to imagine it something like this. In the elevation view, I'm just drawing it, something like a section, something like this, okay? Section in this direction, if I try to show you, if I cut it across like this, generally you have it like this. So if you see this building, at 150 mm, and generally you have, this is your finished floor level. So in between, I've got my lift shafts or staircase shafts. You agree? So already this wall will act like a fire barrier. So my nozzles will be from your external wall to here only. I'll have my nozzles. Understand? I'll have my nozzle only in this direction. Again, I'm having it this location because the wall itself will act like a nozzle, like wall itself will act like a fire barrier for me. Understand?
Yeah.
Am I clear?
Yes.
So
Yes.
we try to reduce, we try to utilize those structures so that number of nozzles or water demand will reduce. I'm clear. We'll try to utilize this because obviously you can even do compartment by keeping a continuous one also, but that will increase your flow rate and water demand. So cleverly, whatever you do, if you have some physical wall which is already having a fire rating, so you will utilize that particular, wall or something to reduce the number of nozzles. Am I clear?
Yeah. Yeah. Chaitanya, can you give name for zoning like 1, 2, 3 so that
Let's put that. Yes, yes, yes. Size is too small. Zone A, Zone B, Zone C. Right?
Yeah.
Okay. Now what we're going to do is basically we will have a structure something like this. So I'll have a fire pump anywhere, or probably I can, because this is probably your basement 2 or basement 1, and from basement 2 the pipe of the fire pipe might be coming in. You agree? If I have two basements, let's say. Of course, for other one also I have to do this same kind of zoning anyway, but I'm just assuming this. Or I might just have a pump room which is a very small and the area is not huge, let's say. So I might have a pump room at any of the locations which I'm not really sure of, but as of now, yeah. So from here, what we do is basically we can have something called as a piping in this fashion. We'll have a piping in this fashion. So let's say that is your sprinkler piping that is coming from your tank. From this one, we will have a pipe that could be connected to both the zones. Understood? It can be connected to both the zones. Clear? So at these locations, I'll just draw this thing. Oh, sorry, it should be that.
is it really required to come in to the center and connect, Chaitanya?
There's nothing wrong, nothing. You can even connect it like this. I mean, this pipe could be somewhere over here, or you can connect it like this from here to here also, you can connect it.
Okay.
Nothing wrong with that. There's
The
nothing like
vertical
center you
line
have
you
to
can
consider.
vertical line you can avoid, no? If keep it all.
Means I
That
didn't get you.
vertical line. Yeah.
Means I didn't understand. Sorry, come again.
From the sprinkler, from the iron piping you raised, no?
No, this is not hydrant piping. This is a separate piping that we have it, which is
I'm sorry.
your
I'm
fire
sorry.
curtain piping.
No, no, yes, it's fire curtain which you took from the wall, right? So
Uh,
from there only you can make a T connection and take it to either zone, or is it required to run that line?
Nothing like that. Nothing like that. No, no, no. It's not required. We can even connect it from this location itself, as you've said. From here itself, I can connect it.
Okay.
I can connect it, but my deluge valve should be at this start point. Understood. I should have. So you can even connect it like this as well. There's nothing wrong with that.
Okay. Okay.
But the equal distribution will do it like that, but it's not mandatory anyway. Understood. Just say polyline. Okay. Anyway, I'll rotate. So for my ease of explanation, I'm just doing it. Is that fine?
No, 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 no.
But you can connect it however you want it to
No.
avoid that
Okay.
particular one. That's
Okay.
what I just said. So here, what we do is basically we will provide something called as deluge valve. We will provide something called as a deluge valve. So that's basically a deluge valve with simple electromechanical, like it's a kind of a solenoid valve. So whenever when there is a signal from the fire alarm, the deluge valve will open.
Okay.
Understood?
Okay. Okay.
So this is nothing but your deluge valve.
Okay.
Deluge valve. So when we have this deluge valve, what we do is simple. The minute we have this deluge, so if I do it in the corner, your pipe sizing will be different. That's the reason. But anyway, so when you have this deluge valve, so first and foremost thing, what you have to understand is your deluge valve. Up to deluge valve, you can use your MS pipe. But after deluge valve in the in the water flow, you have to use GI or SS. GI is 99.99% is what we use because of the cost. The reason why we use this deluge valve is simple. Sorry, why we have to use GI or anything is mandatory is, see, for all your piping systems, you will use your MS. I mean, in case of your firefighting system or HVC system, because in that continuously the water will be there. Water doesn't corrode as such your piping. If it's exposed to air because of higher oxygen content, yes. But your water is stagnant inside your piping, or if it is continuously moving also, because of the water, you have less corrosion. Externally, anyway, you'll use your primer and 2 coats of primer or 1 coat of primer and 2 coats of paint, it will protect it. But whereas if you do not have any water, don't you think it will corrode from internal?
Yes.
So for that reason, up to deluge valve, water will anyway be there from the pressurized firefighting pumps. But from the deluge valve to the nozzles, you will not have any such water as such, except in case of fire. So for that reason, after deluge valve, we'll always go for GI piping. Understood or not?
Yeah, it is after deluge, it will be a very dry system, is it?
Yes, it will be dry system. Yes.
It's up to deluge, it will be wet and pressurized. Post deluge, it is a completely dry.
Yeah, it is completely dry. Yes.
Okay, then clear.
Okay. So I didn't mark the nozzles on the left hand side. Right hand side, however, the nozzles are there. Similarly, the left hand also will be there. Is it fine? We'll just
Yeah.
write it down simply. So similar. Specifically something like this. Okay. So now what we have to do is, what is the total length I have to take, and then we have to worry about the nozzle, each nozzle flow rate. Anyway, what is this length I got it? Length is how much? 8,000. In that, I have to remove this width of your, firefight, your, this one. So I'll do one thing. Small autoless program to calculate the total length. That's it. So these are the three lengths of the pipes that I require, three lengths of the lines that I require, right? So total is how much? 138 meters.
Yes.
Do you agree?
Yes.
So we are getting a total length of 138 meters. So if it is 138 meters, so what is the, if per each linear length, what is a flow rate I require? 35 LPM. Do you agree? So I'll just use the basic calculations again. Okay. Now, what is the length? What is the total length? Length of the wall is how much? Length
138.
138 meters. Alva?
Hmm.
Length is 138 meters. So, per running meter, how much is the flow rate you require? Flow
30,
per running meter?
35.
35 LPM. 35 LPM. Alva? So, total flow, how much I require is equal to 138 into 35. So, that is 4830 LPM. I got it. Now, I can directly count the number of nozzles or not?
Then
Calculate the number of nozzles. So, select similar list. So, total number you got is 70 numbers are there. So, total is 70. 70 is number of nozzles. So is equal to total, how much I can take it is equal to total each flow rate is how much is equal to divided by this one. So automatically around 16 and LPM is what I have it. Understood or not?
yeah.
So each one is 16 and LPM is a flow rate. That is what it clearly says. Generally, the length will be 60 to 80 LPM you'll have per each sprinkler or each nozzle. Understood?
Okay.
Am I clear or not?
Yes.
Or
Yes.
is that yeah? So automatically that will be the case. So now what I have to do? So you come to know the total number of nozzles are 70 and the LPM is 69 each nozzles. Clear?
Yeah.
So the flow rate requirement is for 2 hours. So water demand if we do it, water demand if we want to do it, it's simple is equal to 69 LPM into 70. So anyway, we already know this value is 4830 LPM anyway. Is equal to 4830 into, we have to calculate into how many minutes it will be?
120.
120 minutes. 120 minutes divided by 1000. I'll come to know the cubic. So around 600 cubic meters of water I require just for this. Understood?
Okay.
Am I clear?
600 cubes required.
Yeah, obviously 579 cubic meter. I mean, generally you'll not have this much bigger basements because 80 meters and they're almost like 1 lakh square feet I'm speaking about. You'll have other
Hmm.
partitions also, but yeah, if you have a design layout like this, then it's mandatory because I've
Okay.
just randomly created in fact, but
Okay.
generally you'll have 1 or 2 partitions max. That's it.
Okay. Okay.
Generally, you don't have this much single basement also,
Okay.
if you see. So your basements will not be this much. 80 meters by 90 meters is quite huge, if you see.
So, Chaitanya, what is the minimum number of compartment we should have in any building? Like minimum has to be two or one
Ah,
will not suffice.
see, compartments is basically the separation that you have. Eh? For see, it's not that mandatory. See, if it's only one compartment, there is nothing like you have to create a fire barrier, right? If it's only one single compartment, what will you barrier it from? It is basically making sure that fire or water doesn't spread from one area to the other area,
Correct.
right? So if you have
Yeah.
only one compartment, there's nothing like that. So in many of the cases, what they do, you'll have some civil structures in between. So you don't need not really worry about this in the first place.
Okay. So minimum, you're saying minimum we can have one compartment also.
Obviously, you can have it, right? So if they make it with, say, if the project is small, let's say, I'll just give an example. Let's say,
2,500 square meters we have.
which one?
2,500 square meters our basement area. In that case, we should have only one compartment.
Why this is nothing is there? Hey, where is this drawing? Oh, okay, it's right here, right? Tell me. You were telling something. Sorry.
See, if you have a basement area less than 3,000 square meters, assuming we
Then
have
you
got
need not
2,000,
even worry about this compartmentalization at all.
we don't require compartment.
Why? Because it is lesser than 3000 square meters, and why should you separate it again?
Not separation. We should still have a no compartment required. Is it less than 3,000?
Less than 3000. What? See, why are you creating a compartment? Because from that, I mean, if you have a fire also, fire doesn't spread rapidly throughout the building,
Right, correct.
right? So if it is lesser than 3000, you need not worry about it in the first place.
So you don't require water curtain
No, you don't require it. So that's the reason 80 to 90% you don't see water curtain system in the first place.
Okay. Okay. Can
That's a
you
rare
zoom
application to use it.
the zoning area made no zone ABC? Can just show that area.
Hmm. Yeah.
So as per this design, if there is
Hmm.
a fire in zone A, I think the water curtain between zone A and zone B will operate, correct? No?
Or no, that's also we don't do it like this. So what do we do is basically approach. If you want, you can program it, but that's again how you should have two separate deluge well. You're
No.
like, but you can't be sure at what time the fire is there. So anyway, you have to provide the total water compartment. So what you do is basically your fire pump. What you will be selecting is for the total one only.
Okay.
Understood?
At any see, suppose here we have got three zones. If there is a fire in zone B, obviously both the
Right. Both the things
water
could be
curtain things will
operating.
operate. But
So
my
whenever there is a fire alarm inside your basement system that's there, after more than two detectors or anything, it detects fire.
hmm.
Automatically that will be integrated to this particular one. So automatically the fire this deluge well will open.
But see, now it is only three zones we have made. Out of the two apps to operate, if the worst case of zone B is there's a fire in zone B, it's
Hmm.
not spread to zone A or zone C, so both the sprinkler operate. So I've got
Yes.
multiple zones, like 10 zones and all. That case, how this works.
I've never seen any project with 10 zones. That's way too huge. But
No,
anyway, in that case also you should take the total flow rate. Probably you'll split it into multiple tanks and you'll have like multiple deluge valves. But everything will be operated anyway at the end of the day.
everything will be operated, isn't it?
Yes, yes. Because when there is a fire, it's mandatory for you to provide a curtain. That's the
Okay.
reason. And once there is a fire inside the building, if there's a real fire, you can't risk it by taking, okay, in that area, the fire is not there. Okay.
But in case there's a fire, it may not happen in all the zones, no? Like how we did the sprinkler area of the things. Accordingly, like
Sprinkler is
we can get.
different. See, this is also, that's the reason instead of this, nowadays they are going for this fire curtains,
Mhm.
physical fire curtains.
Okay.
Okay, so anyway, I've given a probably wrong example. This time I'll write some practical case and I'll explain you. I'll show you one project, just a sec. Practically, how will it be? Just a sec, because this project is very huge. It's in fact like a kind of a 1 lakh square feet or something. It's very huge area. What if you take in its example? That's the reason you got this volume. But generally, if you take it, just a sec, data design jobs. Ground floor, basement two, basement one also we had.
Sir, is this fire curtain depended only on area or it also depended on this natural ventilation thing and all?
Nothing related to ventilation according to the area. Solely on the area you have to just a sec, I'll show you. The general decent sized buildings if you see. So this is a general building if you see it. Just a sec. Firefighting which generally if you see the firefighting system, you'll have so generally lift area or something you have it at the central area also along with the sites for building. So you'll create it like this. See, you have partition. So if you see it, we can see the building over here.
Yeah, yeah.
You hardly have one, two, three, four, five, and this is second civil. So that's the reason we didn't do any splitting. We didn't have any nozzles over here. Again, you have it here. So this particular one is splitting this entire building into two parts.
Okay, okay,
So like that, we generally have 99% of the cases. Understood?
okay.
Yeah. Because initially, what I've taken is probably a wrong this thing, because of which, the numbers are exaggerated. But anyway, generally you have it something like that. Am I clear? But
Okay.
yeah, if you have bigger, then you have larger volume. So you might not require. So what you will do is you'll consider this as a separate system, this is a separate system. You'll have a separate tank here and separate tank here. Yeah.
Yes.
Okay. So when you have this deluge system, the pipe sizing is simple. You can consider your 6 FPS or 8 FPS velocity and friction factor not exceeding 4 feet per 100 feet, and then you do your pipe sizing. So you guys are already plumbing consultants, so I need to teach you about pipe sizing specifically. And you'll select your pump head calculations for this. So I'm skipping pump head calculations directly. I guess that should be fine for you guys, right? You're already aware of pump head calculations.
If you have any format, can you share us? I mean, if at all you've done another calculation, you share us so that we'll work on that.
For HVAC, I'll have it. For fire, I don't think I have it currently. I'll just check it. See, simple. Any pump, basically static head, velocity head, pressure head, friction head. That's it. So from hydraulic connection of the sprinkler, you already came to know at the starting point what is the pressure head that you require or the head that you require. And then I'll add static head, velocity head, and the frictional head. That's it for the remaining valves and all. But anyway, for HVAC, I have it. I'll try to get for sprinkler system as well. Let me see. I should have it. I'll just check it once.
Okay.
Okay, I'll try to share it. But you want me to explain it or not required? How do we
Sir,
select a pump head in the first place? Yes.
yeah, you
your
explain
pump.
it, sir.
So you want me to you want me to take that
Yeah.
class on pump selections?
Yeah.
Okay. Okay. So tomorrow we'll work on that one in that case because it's a bit bigger topic. We have to understand about the type of heads and all. So tomorrow shall we work on that?
Yeah.
Pump head selections? I mean, how do we calculate the pump head in the first place? Is it fine?
Yeah.
Yeah.
Okay. So tomorrow I'll take a lecture on pump head calculations. Basically, for any kind of project, how do we work on pump head? Yeah. So anyway, so this is a short note on your calculation portion. Understood?
Okay.
Yeah.
Sir, do you have any project like wherever the 3 zones you have worked on?
No, till now maximum I had is like 2 zones only.
Okay, okay,
As I've told you, most of the jobs what I do is actually HVAC. Very few firefighting jobs is what I get as a consultant.
oh,
So mostly
okay,
because till now what we have marketed ourselves as HVAC consultants previously when I was running my own. So that's the reason mostly I get HVAC jobs. Yeah, fire also we do it, but that's comparatively lesser volume. Okay. So generally, most of the time, plumbing consultants itself will be working on fire. Most of the projects, what I see is
Yeah.
yes,
True. True.
right.
Yeah.
Smaller scale, smaller projects, smaller consultants. If you see, not like a design firm, obviously. Generally, you have plumbing consultant who works parallelly on firefighting as well. So they get most of the projects on firefighting systems if they're a plumbing consultant, especially. So shall we proceed further?
Yeah.
sir, here we can eliminate sprinkler system or we have to consider like,
No. Yes, sprinkler is different. Water curtain is different. So when you
okay,
have
because
sprinkler, if you do not have sprinkler, bloody each area should not exceed more than 750 square meters, not
okay, no,
3,000.
no, like
So your density
wherever
will increase a lot.
okay,
Yes. Along with sprinklers, parallelly you should have this.
okay,
Understood?
Fire spread ಆಗ್ಬಿಡ್ತದೆ ಇದು.
but at that location we are having water curtain, no sir. So
And that
No,
is only
ಏನಂತ
very
ಗೊತ್ತಾ?
small location, right? What about the other area? In zones,
uh,
how
I'm
will you
asking,
contain?
I'm asking it that location only, sir. We can eliminate. So distance we can consider more, no? Like we are having
Generally,
3
what
meter
we do
minimum.
is technically yes or
Mhm.
no. For example, deluge because water curtain pump is a separate pump.
Yes.
Okay. What if it doesn't work?
Mhm.
You can't be sure, right? But anyway, there is no rule which says that you can, avoid at that particular location. And avoiding at that simple particular location also will not help us a lot.
Okay.
because water curtain will spray at that way. You already saw no, there's a little lack, just like a wall barrier. That's it. It will not spread. So
Okay.
just adjacent to that, if you have fire also, it will not be able to extinguish it properly. Understood?
Okay.
For that reason, we generally do not have any exclusions. That's it.
Okay.
Yeah.
Okay.
Again. Fine. So now coming to what is the flow rate and what is this thing? Okay, this might be confusing for us because the volume of water is quite huge. If it is a smaller, then the calculation might be more simple for us. But anyway, because of these larger volumes, we got this 579 as your water, 600 cubic meters, and your water curtain pump volume flow rate should be 4830 LPM. Understood? So your pump capacity will be 4830 LPM. Understood or not? And your water should be 120 minutes of this particular one. So obviously it will be 579.6 cubic meters volume of water. So this tank will be an additional requirement to your existing fire requirement. That means you already have your sprinkler demand and hydrant demand, right? According to that, you have already calculated certain volume.
Yes.
Yes or no?
Yeah.
Right. So that volume you have already added. Along with that, you will have this guy. So when you have, say, for example, that you got some cubic meter, that and this you have to add it together to calculate the total fire pump system. And for this, you have a separate pumping station. That means you will not combine it with your hydrant sprinkler, and you can't use your existing hydrant or your sprinkler system to use your water cutting. This water cutting system is entirely an isolated system. So, though your tank is common, you will take from a common header or a separate header you will create for this guy, and then you have to have a separate pump station from which you will connect it to this entire water curtain system. Understood or not?
Yes.
Sir, having
Yeah.
separate common header or having separate tank only for water
If you
curtain
want, you can
system.
have a separate tank. There's nothing wrong with that, but generally we combine the tanks. I mean, you add the total volume to create a common set of tanks. It's not mandatory that you should have a separate tank, but if you create a separate tank also, there's nothing wrong with that.
Okay. So it's not mandatory. We can have combination of tanks.
No, but you should have water circulation, and also again you have to create some kind of water circulation to provide into the plumbing pump, plumbing tank, and also that kind of creates confusion.
Okay.
So generally, what we do is we add this demand also into the thing, and then we create. I'll try to show you that project which I showed you a while back, and basement two I might have. Just a second. Try to show you in this case. Generally have it something like this. Plumbing, pumping, this plumbing alva. Another the pumps are there. Yeah, you have it something. Yeah. If you see it here, these are your five tank where around 90 KLD, 90 KLD, of course, for this particular demand that was required. If you see, there is one electrical pump here, which is basically one for electrical pump. Basically, you have both your sprinkler pump for upper flow. I mean, you've got this pump, which is the F1, F2, F3, F4. You have these pumps. See, you have a fire pump, diesel pump. You have got main fire hydrant pump, and your jockey pump and water curtain pump, which is again separate. You can see, according to the number of nozzles, will decide this particular volume. Understood?
Okay.
This is completely a separate pump altogether.
Mhm.
If you see it here, so this is separate pump. So we have a common suction manifold. From the suction manifold, you have a water curtain pump, and from the water curtain pump, you will create it to a separate line is going. You can see the orange color one, right?
Yeah.
So from this, it is splitting on the left hand, left and right side. You can see it's something. Am I clear?
Yes, sir.
Like this, you basically design your like the water cutting system. So you'll have a separate pump, but the tank of the volumes you could basically add it together. Clear?
Clear.
Okay. So next we're gonna work on the so this is nothing but your water cutting system, like whatever I wanted to explain. So you've got any queries on this? I'll be sharing you the slides, don't worry. So you've got any queries on this?
No, sir.
Okay, okay. So we will stop this topic, and the next will be your pump head calibrations, and then it will be your fire alarm, and then it will be your passive fire cutting systems. Okay. So is it fine? We'll wind off today, or we'll continue? Hello.
Yeah.
Yeah, we can.
We'll continue or wind off? I didn't understand. I mean, I asked you a question.
If required, can continue, no problem.
Ah, okay.
Either way, I'm okay.
Ah, fine then, fine. Then we'll continue till 7 and 8. Yes, let's see. So when you take, okay, so I'll just stop recording. Just a second.